Hello, my name's Joe Hinkle. This is going to be a fairly long and you may want to call it a complex video. I'm going to demonstrate some new capabilities within the HinksPix PRO controller, namely the Design tab and your Manage controller configurations. What I'm going to show you is how you can go from Xlights, configure your HinksPix PRO controller, back into Xlights, and have everything work. We'll be using my smart technology during this demo. And so let's just look at Xlights. Let's say we've spent the majority of COVID here, and we've created a Xlights preview show, and we have a bunch of props. Okay, what I'm going to show you, I always like to start at the physical objects themselves, meaning you've got some pixel strings and you've got some hardware that you hook those pixel strings to. So just to get a definition out of the way, my terminology of a port is if you look at your hardware that you attach your strings to, typically somewhere along the line it's going to end up with a green Euro connector. What you plug into a green Euro connector is I'm referring to a port. So a port will typically have a pixel string on it. In this demo, we're also going to bring in an AC controller, all part of my smart long-range technology. What I'm going to do is show you how to take various components of this show and hook them up to a HinksPix PRO. Namely, we've got a megatree here. This megatree we're going to put on a standard SPI board. It is 16 strings at 50 pixels per string. We've got a house outline. If I can click on it, there. If you notice, we go right on across the tops. We go right on across the tops, all the way down. Now, the way this is going to be designed, I'm assuming I'm going to put a long-range receiver up here in the middle. I'm going to drive these four off of one long-range receiver and this four off of another long-range receiver. We've got a humongous size megatree down here that's got 200 pixels per string. There's 16 strings. I did that on purpose because I want to show you a prop that has more pixels than you can get into a single universe. We've got some mini trees, and we've got some candy canes. And I'm showing 16 dots here. This is going to be for our AC controller. Now, when you're in Xlights, if you're driving an AC controller, you got to come down and pick single color. That tells Xlights that it's one channel per output as opposed to a pixel. Okay? What we're going to do is we're going to put these four mini trees, these four candy canes, and this AC controller on one long-range receiver. So in short, we got a house outline, we got two mega trees, we got some four mini trees, four candy canes, and 16 AC incandescents or straight non-changing color LEDs that we're going to drive. If you notice my controller page, you see nothing here. If you're just starting out with Xlights, Xlights has the capability. They like you to tell you what controller you have, and then you'll end up with a single line entry here with all kinds of universes and channels, and Xlights will try to properly configure your controller for you. When that works, it is absolutely great. The problem is this is September 2020, and Xlights has not implemented, I provided them with an API on how to communicate with the controller and configure it for my smart long-range technology. As of the making of this video, they don't have it implemented yet. When they do, that'll be very good. I'm showing you how you can implement your design without using the auto configuration of Xlights. Now, if you're using LOR for your sequencer, the same kind of scenario. Don't get hung up that this is Xlights and it's not LOR. My explanation is going to be strictly on E131 protocol universe channel count, which you can do here in Xlights or you can do in LOR. So let's go over to the HinksPix. Now, I did a factory reset to start this out, which means it's just going to come up with 16 universes at 150 channels per universe. Now, first of all, to start off, under miscellaneous, there's now a managed controller configuration. If you click that, it will save the configuration that is currently on the board, not changes that you've made, but currently on the board. It'll save them to an SD card that you've installed in your controller, which means if you have a Halloween show, if you have a 4th of July show, if you have a Christmas show, you can save each of those configurations on the SD card and pull them back up. If last year you had one show, but this year you added more pixels, more lights, more props, you can go ahead and bring up the previous show, make some amendments, resave it to a different configuration. Needless to say, you don't have to be retyping everything. You can bring in and save different configurations. What we're going to talk about is the new design tab. Now, the new design tab is to help people primarily that are using my long-range receivers. I've got a lot of videos out there on how to use them. I know when people start trying to use it, their eyes roll in the back of the head. It's like, oh, this is just too complicated. And I keep telling everyone that if you go through the videos and you understand it, somewhere along the line, a light bulb's going to turn on and say, wow, that was easy. Now I understand. To help people that haven't gone through that enlightening process, I've implemented this design page. Now, nothing comes without a price. In being able to implement a design page, I've had to make some simplifications, meaning every port, meaning every green Euro connector that has a pixel string attached to it has to be its own universe. Now, if you're doing it by hand, you can reduce the number of E131 packets that are transmitted, but you got to be able to know how to pack the universes to create your streams, etc. This design flow will take you beyond that. The conclusion of this design will automatically set your long range and your SPI output settings, automatically create your E131 tab. Once we have that, we'll go back into Xlights, we'll add that information to Xlights, we'll associate those universes and channels back into your props within Xlights, and we will have a complete configuration. So let's start off with the design. This is brand new. There, I just put in my SD card. Right now it says there's no design saved, which is just fine. If I had a design saved, I could just say click on open and it would open up. What we're going to do is we're going to create a brand new design for the Xlights show that I just showed you. So let's give it a name. Let's just call it Christmas 20 for 2020. Okay. Now, coming down, this says, what boards do you have attached to the HinksPix Pro? Well, you can have 3 long-range transmitters. You can have 2 SPIs. You can have 3 of these boards. Typically, you can't have 3 SPIs, but you could have 1 long-range, 2 SPIs. You could have 2 long-range, 1 SPI, or you could have 3 long-range. In the example that I'm showing here, our first board is a long-range board. So we're going to pick long-range 1, and we're going to check it. Now, the reason why you got to pick it here and here is because we can save configurations that are not actually implemented. What I mean by that is during testing, you can easily just swap your pixels around without having to reconfigure that. That's one of the reasons why I'm double selecting. We have an active SPI port. We're going to assign that SPI port now to SPI 1. And the reason I did this is, as I said, I could engage both long range 1 and long range 2, and then up here I could have two different capabilities and I could just pick them as such. Okay, we're going to leave them at 100% intensity right now. Now, when you're talking about a long range transmitter, if you look at the physical transmitter board, it's got 4 Cat5 cables. This represents the 4 Cat5 cables that are on that long-range transmitter board. As I said, we're gonna take one of the Cat5 cables and we're gonna drive the outputs of our house outline. We're gonna take another one that's gonna drive our big 200 pixel per string megatree, and we're gonna take a third one that's gonna drive mini trees, candy canes, and the AC controller. And we're not going to hook anything up to Cat 5 here. So we're going to pick and we're going to identify that we're going to use 3 Cat 5 line, 3 Cat 5. You got 12 because you got 4 Cat 5s per long range. So maximum, you got 3 long range times 4 Cat 5s gives you the ability of picking 12 Cat 5 categories. When you check this, it actually ends up populating this down here. Okay? So that's just kind of explaining that. The first one, we're going to turn around and we're going to associate now what we're going to do with Cat 1, which is right here. We're going to assign that to our very first port cable on the board. We're going to assign this to Cat 2. And well, let's just do this. Let's just make this Cat 4, and we're going to make this one Cat 4. I did that purposely to show that these cable 1s, 2, 3, 4 do not have to be in sequence. You're just coming down and you're picking an activation that you've done down here. Now, the first thing we need to do is we need to tell the system what strings we have. Remember, a string is a connection, or a string connects to a port, which is effectively a green Euro connector, and we're going to give it a name, and we're going to tell it how many universes and how many channels per universe are in each of those strings. Let's go ahead and do the house outline first. Now, I'm simply going to call it H1 for house outline 1. That one happens to have, we're going to make this universe 1, and it has 10 pixels. We're going to add some more strings. We're going to call house outline H2. Let's just get our house outlines in here. H3, H4, 5, 6, 7, and 8. And the second one is 2, universe 2. Oh, there we go. I made my first mistake. This is pixels. So pixels times channels is 3. So that is 30 channels. Okay? This setup is channels. So the next one is 50 pixels, which is 150 channels. Next one's going to be universe 3, which is 25 pixels or 75 channels. We're going to assign the next one to universe 4, colon, which is 40 pixels, which is 120 channels. Number 5, we're going to assign that to 5, and that is also 120 channels or 40 pixels. Number 6 is 50 pixels, so that's 150 channels. 7 is 150 channels. And finally, we get back down to the left side of the house, which we're going to call Universe 8. It has 10 pixels, so it's got 30 channels. Now, let's add some more strings. Let's do that big SPI megatree, okay? It has 16, so let's add some more strings. So we'll call it SPI megatree 1 for the first string, SPI megatree 2, SPI megatree 3, SPI megatree 4, SPI megatree 5, oh, did that wrong. This is 7. This is 8. I'm not talking, so you haven't lost your audio. You just don't need to hear me sit here and count. So there we have our SPI megatree. Let's go ahead and add our long range SPI megatree, which is on a long range 16. So this one, we're just going to call it T1 for tree 1. Okay? And we got T2, T3, T4, T5, T6, 7, T8, T9, T10, and we got our megatree. Let's just go ahead and add the rest right now. Let's just get them out of the way. So we'll add a couple more strings. Now, so we have the 2 megatrees. What we have now is we have the small trees. Okay? So we'll call it small tree 1. We got 4 of them. Small tree 2. What did I say, MT? It's supposed to be small tree. So there we have our mini trees. Let's get our candy canes. So we're just going to call it candy cane 1, candy cane 2, candy cane 3, candy cane 4, and we have our AC board. We're just going to call it AC for now, okay? Because remember, we're dealing with pixels here. That's a 16-channel AC long-range receiver, but we're working with pixels. So that should now define all of the strings that are required to be connected to our show. Now we come up here to the megatree, And the mega tree was 16 strings at 50 pixels per string. So we're going to start this mega tree at universe 21, and it's 50 pixels, so that's 150. 22 at 150. 23 at 150. And you might be asking yourself, why am I not keeping the universes sequential? Universes is a number that defines an E130 packet address. One of my suggestions is that you keep gaps, so if you add in the future, you can just go ahead and add within that block of universes. So as you see, I went from 1 up until 20. They also allow me to have a universe number where the last number is associated like with the string. That's just for ease of remembering and things of that nature. And I know this is somewhat tedious, but I chose a big show to have you walk through exactly what we're doing here. Oh, made a mistake. That's 31. 32 at 150. 33 at 150. 34 at 150. 35 at 150. And 36 at 150. Up, 36, not 2. Now we're into our big tree. Now again, this big tree is going to be driven by a long-range, smart 16 pixel, and it has 200 pixels per string. So you can only put 170 pixels in a universe, so 170 is less than the number of pixels, so we have to use 2 universes. So here, we're going to go universe 101, and we'll call it 100 pixels, which is going to be 300 channels. And this is going to be 102, and it'll be 100. So this 200 pixels that we're going to attach to this string is going to be transmitted, received, and packed, receiving universe 100 that has 100 pixels on it. Also then universe 102, which will have 100 universes on it. Now this is going to be 103, 300, 104, 300, and at this time, I will probably do the magic of video editing and jump down to the bottom so you don't have to see me sit here and just do typing. Okay, we've done with the long range board, the long range high pixel count megatree. Now we have our small trees. Our small trees consisted of 50 pixels per string. So we're going to do 201, and 50 pixels is 150. We're going to do 202 for 150. We're going to do 203 at 150. And we're going to do 204 at 150. Now we got our candy canes. Our candy canes are 18 pixels. So we're going to go 221 at 18. 18 times 3 is 54. I hope I did that right in my head. 18 times 3, I think that's 54. 222 at 54. 223 at 54. 224 at 54. And now we come to our AC board. We're going to do that at 231. Now, your AC board always requires 6 pixels, okay? Or, 18 channels, because it has to be pixels. And that requires 16 outputs. So in order to get that into a pixel space, we need 6 pixels, which gives us 18 channels. And I'll show you in Xlights where we do not want to use the first 2 of this 18. We want to use the last 16 of these. Okay? So that, all of this now defines our string. Let's go ahead and save this just so we don't end up losing it. So the design has been saved. Now we come down. Now that we have our strings identified, now we have to go ahead and start assigning them to our ports. And the way we do that is we said that this is Cat5 cable 1, cable 2, cable 4. Remember we said Cat5 cable 1 is going to contain, it's actually going to contain 2 4-port SPIs, because that was going to drive our house outline, our smart 4-ports. So let's go ahead and we're going to add 2 smart 4s. And these board IDs, those are set. Remember, whatever number you put here, you have to set the dip switches on the physical long-range smart receivers to match. So we're going to call it 0 and we're going to call it 1. Now we have to identify what string we're going to do here. And if you recall, this was going to be H1, H2, H3, H4, and then this is 5, 6, 7, and 8. We're going to drive them that way. And the way I've done that is you click here, which means I want to assign this string, and you mosey up here, and you say, I want to do that guy. And you get a loud beep in your ear to tell you that you have that association. So if this beep is too loud, I apologize for that. And now it's just a matter of coming down and associating a string with each of our outputs. And we do H4 here. And this one's going to be H5. H6. H7. And H8. Okay? Now, remember, this is our small tree. It's a mega tree, but it's our small mega tree. We're going to hold off on that. The next one is we're going to do our big mega tree. And we're going to be driving that one off of Cat5 cable 2. And that is going to be a Smart 16. And we'll leave that at board address 0. Now we assign our ports. Again, we click, and that is T1. Now, I will more than likely go through the magic of video editing and not have to have you sit here and listen to me boringly tick these things. So we'll be back in just a minute. Okay, so I've just concluded assigning to the Smart 16 the 16 strings that we've identified above. The next thing we're going to do is we're going to do our 4 mini trees, our 4 candy canes, and our AC adapter. Okay? And that one was going on this cable, which happens to be cable. It's attached to cable 4. Okay? Now remember, it's cable 4, but it's in... Oh, hang on. That's 4. Yeah. Huh. I think cable 1, cable 2. Okay, I can see a little bit of a bug I just got here. Cable 4, but it's actually in position 3. Okay, but we're calling it Cat 4. So, we're coming down here, and this is going to be 2 Smart Spies, and it's going to be an AC. Again, 0, we'll just say 1, and we'll call it 2. Now, remember, each Cat 5 can have 16 unique identifiable smart long-range receiver objects on them. That's why I'm just starting off at 0, 1, 2. But I can make these numbers whatever I want, and this 0 is not the same as the 0 on the other one. So this smart was our small tree, which is small tree 1. So small tree 1. Small tree 2. Small tree 3. And small tree 4. And we're going to get our candy canes now. This is our candy cane. Now remember, when you have these smart receivers, each is identified by a dip switch ID, and that's what this board ID here is. And now we go to candy cane 3. And we go to candy cane 4. And lastly, we're going to do our AC. And now, even though it shows 4 of them here for the AC, what it's actually doing, and now we have to get somewhat technical, each Cat5 cable has 4 twisted pair lines, which I call a stream because it has a stream of data. So, the stream, this Cat5 cable will have the channels associated with ST1 followed by CC1. So these 1s combine a stream, these 2 combine a stream, 3 and 4. What I'm asking here is pick one of these 4 streams that you're going to put the AC. And we're just going to use the very first stream. So we're going to make that our AC. Let's go ahead and save this again. Now the last thing we need to do is our large SPI megatree, which is down here. And that is simply going ahead and then associating our small tree, which are ST1. And again, by the miracle of video editing, I will not torture you by watching all of this. Okay, we're back from video editing, and I have successfully assigned all of the small megatrees to the spy board. Let's go ahead and save this one more time. It's been saved. Now, let's perform a design check. When you press this, I go through the design and I'm trying to catch some errors that you may have made a mistake on. So we do a design check. Controller port is limited to 4 universes. Port 2 has 2700. Oh, there we go. Has 2700. Controllers limited. Port 2 has 27. Okay. So we're back, and now we've assigned all of the strings to the actual 16-port spy board that is situated underneath the HinksPix PRO. So then we can come up to the top and we can perform a design check. And this will check various things to make sure that we haven't made a mistake, make sure that there aren't too many channels on any one port, etc. So we click design and we get an error. It says controller port is limited to 4 universes or 2048 channels, but port 5 has 2400 channels. Why is that? So we come down here and look, and port 5 happens to be this Smart 16. Well, we're only putting 2 universes on each port. Why is that a problem? Well, the problem is 2 universes on a SPI 16 non-long range is perfectly acceptable. But when you try to put it on a Smart, remember, there's 16 ports, but it's coming down 4 streams. And there's 600 pixels or 600 channels per port. There's 4 ports on the stream. That's how you get to 2400. So we've got to go back and reevaluate our design here. Originally, we had this 16 as being with the HinksPix PRO and this one being a long range. So we're going to have to change it. We'll make this 16 the long range, and we'll come this one off of the SPI board. So we come back. So what we've got to do is we've got to change all of these strings to represent the Smart or the ST, because I don't want to go up here and change these. So all these T1s have got to go down here, and all the STs have to go up there. So I'm going to pause here, and I'm going to do it offline so you don't have to worry about getting bored. Please pause. And the magic of video editing, I have now transferred the 200 pixel strings over to the physical SPI board, and I have moved the 16 by 50s to the Smart controller. Now if we come up and we do a design check, it comes back and says everything is okay. Now what we do is we turn around and we're going to do a save a controller. And what it's going to do, it's going to save this configuration. It's going to build the configuration, both the port configs and the E131. It'll also take the DMX information and other such things that are associated with the current controller, and it will save them. So we click that, and it has been saved. So now we've taken this design, and if we look down, you can see there's start addresses. And what I'm going to suggest you do is you take a look at these, and you can double check. I always recommend that you go back and watch my videos on how to do this specifically, and you can use this to double check to make sure your understanding is correct. So now we can come over to miscellaneous settings, go manage controller configuration, and we see now we have a Christmas 20 as a saved configuration. Remember, I'm still in factory reset. So if I was to go over here to E131, notice I still have 16 universes. I come up here to long range. I don't have any smart configurations. So we go to manage controller configurations. And we have a Christmas 2020. So we go ahead and install it. Comes up and says, hey, you got to reset to make sure it's operational. So we okay. We're going to do a reset. And now what we've done is we've taken the configuration that's been saved on the SD card. We've placed it in the controller and said, you are now the active configuration, and upon reset, that new configuration becomes active. So we'll double check it here in just a second.